This video will cover using graphs to understand data. We will cover 3 types of graphs: bar charts, box plots, and histograms. It's important to know which graph to use. If the variable is categorical, look at it using a bar chart. If it is continuous, you should examine it using either a box and whisker plot or a histogram. A bar chart translates the data from frequency tables into a pictorial representation. It depicts categorical variables and shows frequency or proportion in each category. This bar chart looks at the frequency distribution of patients with pulmonary embolism, which occurs when one or more arteries in the lungs gets blocked by a blood clot. Notice that this is a binary variable with only 2 possible responses, yes and no. Yes is coded as 1 and no is coded as 0. The frequency distribution of a binary variable shows the number of patients in each group. It's much easier to extract information from a bar chart than from a table. This chart depicts shock index, which is the ratio of heart rate to blood pressure and should lie between 0.5 and 0.8. The higher it is, the greater the risk. Shock index is an ordinal categorical variable. The vertical bars here represent the number of patients in each category. The shape of a distribution describes how the data are distributed. Measures of shape include symmetric and skewed. The first thing we're looking for in any continuous variable is the shape of distribution. What are the boundaries of the data points, and how are they clustered? If a few small values are mixed in with a majority of values being much higher, the data will have a left or negative skew. Likewise, if we have some large values mixed in with a majority of small values, the distribution will have a right skew, or we say it is positively skewed. If the distribution is balanced, it is symmetric. We can also observe skewness by inspecting the values. For instance, consider the numeric sequence 49, 50, 51, whose values are evenly distributed around a central value of 50. This produces a symmetric shape. We can transform this sequence into a negatively skewed distribution by adding a value far below the mean, 40, 49, 50, 51. This produces a left skew. Similarly, we can make the sequence positively skewed by adding a value far above the mean, 49, 50, 51, 60. This produces a right skew. A box and whisker plot provides an easy way to examine the entire distribution of a variable, and it's also very useful when we want to examine relationships between 2 variables, where one is categorical and another is continuous. Let's look at the box first. The bottom of the box represents the 25th percentile, while the top of the box represents the 75th percentile. The line in the middle represents the median. The bigger the box, the greater the spread of the data. The whiskers in the box plot do not necessarily represent the minimum and maximum values. They show the minimum and maximum only if these values are less than 1.5 times the interquartile range. If the values are bigger than that, the whiskers represent 1.5 times the interquartile range, or IQR. Values outside that range are represented as dots. In the example here, note that there are many dots above the top whisker. This is a quick and easy way to check for outliers. We can look at the same shock index data with a histogram. The dots in the box plot showed us that there were several large values greater than 1.5 times the interquartile range. The same is represented in this histogram, with the right skew. There's no single rule of thumb for choosing bin sizes. The bin sizes you choose will depend on the research question you're asking. Here, using 100 bins shows too much detail, and it's not useful. Likewise, too few bins tells us little about the underlying shape of the distribution. This example uses 2 bins and provides too little detail. Note that the box plot we looked at earlier shows the same positive or right skew that we observe in a histogram for shock index. The median inside the box plot also provides information on the skewness of the distribution. If the median is at the center of the box, the distribution is symmetric. If the data have a left skew, then the median will be pulled to the right inside the box. If the data have a right skew, then the median will be pulled to the left in the box. This concludes our video on using graphs to understand data. Today we covered 3 types of graphs: bar charts, box plots, and histograms.